Okay, if you want to run the Wilson macros for meta-analysis, let me take you through some steps. So we're just going to do a Google search here for the Wilson macros and meta-analysis. I'm sure this comes up really fast. And here we have it, meta-analysis stuff, George Mason, and here's Dave's page. And if you go down on this page a little bit, if my computer will cooperate, which it's not, bear with me. I'm doing it via the remote desktop because I don't have SPSS on this computer. So you go down and you grab the SPSS macros here that you can see. You could take, if you want, follow the others for this. We're going to save the file out, and I'm going to put it into my C drive. I'm running on Windows here, so adjust as needed depending on your operating system. And well, just see, I've already got a macros file there, and I'm going to overwrite the ones that I've got in there, but I'll save them out. And now if I look in my macros directory, there's the zip file, and I'm going to open it up. It already has a previous version when I did this before, and I'm just going to go ahead and extract them. I'm going to overwrite the old ones. You look at the dates of those here, July 2006, extract them. And with any luck, yes to all, we'll have new versions. They look like the very same ones. Now, when you get a README file, you should do something with it. Very, very interesting thing. Read it. So if you bring it up, it has all the instructions how to use the macros right inside it. And I'm going to browse through this quick and see if it still has a problem. It still does. So where it says the meta-reg instructions, you want to change every one of those to read meta-reg, not meta-f. It was obviously a cut and paste error because up here where Dave talks about meta-f is intended. Down here it should say meta-reg. Otherwise you're not going to call up the meta-reg program. Okay. So we've downloaded everything, and if you want, you could even save some time. If you know you're going to go to, you're going to be calling up the mean.es program, you could copy the relevant command out right here because you know you're going to need it once you get into SPSS. Now, I've already got a data set here in memory in SPSS, so yours is going to look something like this. You see I've got my ID number here on the left, D, the standardized mean difference. Let's assume that that one's already corrected for sample size bias. Here's a standard error for each D, the weight, TW, for each one, and then three moderators, MQS, whether it's an RCT, and whether it's what dosage of a treatment it gave is in there. And you're going to want to use syntax. There's really no way to do this without syntax. So I think, do I already have syntax up? It looks like not. And so I'm gonna start a new syntax screen, and eventually the system will reply to me. Oops, I don't know why I did that, but what the heck, we're gonna go to the syntax editor. And I'm going to paste in that command that I took out of the README file. Of course, it's the wrong location because I saved it to macros, so I'm gonna change my, there, now it reads the correct spot. Now you do this, you don't put the macro file itself in there, you just put the, you just say include it. And if you run this, it just says that it's done it. This comes up on the screen, everything's working normal. Go back to your syntax window. And now, oops, am I still in syntax? I guess I am, but I don't know what happened to the, I feel like a dunce when it comes to SPSS because this is the one time every 2 years that I use it. Alright, so if the README file is still up, you can copy out the mean.es command from the README file and go back over here to your syntax, and here we are, and I'm going to tell it to use that macro that I just loaded into memory. But I have to put the right variable names in. So back here, I apologize, my system is really sluggish. Everyone's on the internet today and slowing everything down for me, so this is going to be slower than I want it to be. Hello, system. Watch, it's going to bomb again and come back up. Anyway, the defaults that Dave Wilson has in his example command, you have to make them match yours. And so once it finally comes around, okay, you can see there's the data set again, just for memory of what your variables are. D is the effect size, and the weight is TW. And if you run this, hopefully it works, and you get something called a matrix output. And in fact, what that does is it gives us the output from the analysis. I could quibble with Dave's labels. I mean, I should say K here instead of N, but you see some descriptives, the minimum, the maximum effect size, the weighted standard deviation for those. Down here is really the key information. So here's a fixed effects mean effect size, 0.31, and there's a confidence interval for it. It's highly significant. If you want, you've got a z-value in the p for that mean effect size. The next one shows you the random effects mean, which is almost the same as the fixed. And there's a confidence interval, again, highly significant. And down below here, we've got a random effects variance. So that's what I was telling you about in class, that if you've got a variance that's larger than 0, that means I squared is larger than 0 too. In fact, this output does not include I squared, but you can go to a spreadsheet that we've put on meta-analysisning.com and do a quick conversion of it. The Q analysis here indicates that there is heterogeneity, significant heterogeneity. Formally speaking, we would say that the hypothesis of homogeneity is rejected. Thus, there is more variation in effect sizes than you would expect on the basis of sampling error alone, as I talked about in the last class. So here you have the first model. Now, that's good. Means are maybe relatively uninteresting, but no matter. Let's say we want to do some models. So we might want to do the meta-f command, which focuses on categorical variables, and I'm looking for the right include command here, but it doesn't look like it's in there. So I'm going to go back to my syntax and I'm going to make it up myself and see if I can get it right. Actually, I'm going to go back and copy the meta-reg command too. So here's the command that we're going to have for it. So it gives you the different versions you can use. If you're going to pick from these, you probably want to use restricted information maximum likelihood for these meta-f and the meta-f commands and the meta-reg commands. So, but for now, let's do a fixed effects model. And so here's the meta-f command, and I'm going to copy that into my syntax and just put it in below the others. And, don't overwrite all your syntax. You keep it forever. Syntax is your friend. Whenever anyone brings me a data file, I say, show me some syntax, because it leads me directly to the variables that I need to use. And probably things go a lot faster, so you want to save your syntax. There's the meta-f command ready to run, but the problem is we didn't load it yet. And so, and again, I've got a sluggish system, so it's just not, there it goes finally. I'm trying to make a little space on there. So if we said include C macros meta F SPS, that will, and I'm putting a period at the end of the line. And I'm just going to run that one line to make sure it works. And we should get that same output onto our results screen. I think that it doesn't like this for some reason. Okay, so go back up and see what my command was in the first one that I did. And I'm gonna go back to my syntax again, and I'm gonna fix it based on this. Okay, that should say meta-f. And if I run that one line, I'm just highlighting it and I run it. Hopefully now at the bottom, this is what it's like running macros. Okay, hang on a sec. Again, very sluggish. Can we use other commands? I don't even get a mouse on the screen right now, so this is really aggravating. There we go, a mouse. Okay, down at the bottom. Now it correctly loaded. So back to our syntax, and I can now run my little model. And this is just by default going to give us a fixed effects model, because we've told it just to run the meta-f command. So in fact, here's a meta-analytic model. It's a categorical model, and I didn't know what it was going to show because I haven't run this before. This one shows absolutely no difference between randomized controlled trials and non-randomized controlled. So if randomized controlled trials are these number ones down here, in this bottom row, they get exactly the same effect as do the ones that are non-RCTs. Obviously, this is kind of an artificial example. This is a database that I created for the purpose of demonstrations, but that's not very interesting. Anyway, we've done it. And so this one, you see how it does it. It has QW within groups, and it has Q within. And in fact, those are redundant statistics. The Q within up here is a model fit statistic for the whole set. Because there is no between model variance, the within statistic is the same as the total statistic. So what you see here in the bottom, the total line actually tells you the homogeneity value for the entire meta-analysis without controlling for any moderators. And that should be exactly what we saw in the last analysis with the mean ES. So if I page back up, there it is, 171.46 is exactly the same. This is the analysis of variance analog in meta-analysis, so that's why it's called this up here. Wilson's real good about labeling these, so it says fixed effects model via ordinary least squares. That's great. Like I said, here the within group homogeneity statistics, those would be more interesting if there was actually any differences between them, but because this example has nothing, there you go, it's done. And then at the bottom you've got, so this total here, that's just what we had in the mean ES, so that's exactly the same. The very bottom two lines, effect size results by group, show you the non-RCTs, the zeros, and the RCTs results across, and like I said, identical because I created this data set. Now, if you want to run meta-reg in the very same session as the others, you might be out of luck, because for as long as these macros have been in existence, take a look at this line here at the bottom, and I wish I could at least copy this out, and maybe in the syntax line over here, it'll be easier to see. There's a problem. So I'm going to paste that in here so you see his warning. Running all three macros, SPSS seems not to be able to do these things as part of a single session. Therefore, if you need to, you'll have to break out and do multiple sessions. So in past classes, some of my students have been able to run all three, others have not. It probably depends on versions of SPSS. I'm going to delete that now. We're going to risk it all. We're going to see if we can run the meta-reg command as well. And so here's the command that would include the macro so that we can use it in a session. So let's try running that and see what happens. And on our output screen, it looks so far so good. And now if I'm going to take the very same command up here. I'm going to try to once my mouse comes to life. Someday. This is just the kind of stuff to do on April Fool's Day because, of course, the computer is not cooperating. Bear with me. The internet is occupied today with everyone out there doing April Fool's jokes. That's what's happening. Alright, so here's our last command we did in meta-f. Now we've already got the meta-reg command in memory. And again, you've got to change the meta-f to reg, otherwise it's going to call the meta-f command. I believe the syntax is the same. I'm going to look back at my text file to remind myself. So if we're doing fixed effects models, I'm going to just literally copy this over, and then you'll see how to use it. And again, no promises that this will work. We'll probably have to restart the session, and then we'll be able to run meta-reg. Again, that's why you want to save your commands out. So this is meta-reg, not meta-f. And you've got your effect size here, and your weight here, and then your predictors here. And I'm not going to use RCT for this, we already know. Oh, we could do it just for demonstration purpose. It will show exactly the same thing in just a format, in a different format. So maybe for comparison's sake, let's do it. So the main difference between the two commands is that it says, instead of group, it says IVS. And I'm going to solve that problem. And so we can delete this line because it's no good. This line should run perfectly. And it'll be very uninteresting, but let's run it anyway and see if it runs. Yeah, see, here's the problem. It gets into some kind of infinite loop, and then it won't go any further. So I'm gonna exit from here. I'm not gonna save the output because I don't care. It's all fake data anyway. The syntax, however, I want to save that. So I'm gonna put that somewhere where I can find it, and in a second, that way I can bring it back up. I'll just save it under the default name, and then I can get out of the entire session. And honestly, did I make changes to the data set? I don't remember. Whatever. Now I'm going to bring that data set back up. So bear with me a second while I find the right directory to do that. Oh yeah, I had it right here. And now I'm going to bring up my syntax file again. So if you said recently used file syntax and just bring it up. And now I'm starting a new session, so I've got to include the macro to start with. And boom, I do it, and that looks perfectly right. And now when I run my meta-reg command, here's where things are going to, I said not look interesting. Again, we see that there is absolutely no, so you look at this line, the model showing no difference at all for RCTs versus non-RCTs. And so the beta weight, standardized beta weight is down here, and it's a 0 because there's no slope. And in fact, I would argue the meta-f command is more interesting, has better diagnostics than the meta-reg command, because at least it shows you the results breaking it down by group. When you do it in a meta-reg, you're seeing everything glommed together, and actually that's where the moving constant technique picks up, and more on that a little later, and I'll do a separate talk about that one. All right, so if we do this command again with a variable that I'm sure will be more interesting, let's go back to our syntax, and I'm going to copy my command again, never delete them, if they work anyway. And so I know I have a variable called dose in there, and I'm guessing this would be a lot more interesting. So dose is a continuous variable, and so imagine dose of a treatment. And indeed, look down here, our model statistic is significant. And when you've got a bivariate model like this one, I like to call it bivariate because it's two variables. So you've got one variable dose and one dependent variable effect size. So the model statistic is significant. In fact, if you look at the univariate stat down here for the coefficient, it's exactly the same p-value. They are the same thing when you run this model, at least in a fixed effects model. And what you see is that as dose goes up, indeed the treatment effect gets stronger. That's nice. Now, it doesn't tell you what effect size is at different levels. I mean, you can use the equation of the line for that, but again, look at my talk about the moving constant technique, and you'll get a better sense about how you can use that information altogether. And hopefully I can work a few jokes into that thing as well, but whatever. Here you've got meta-reg run, and what else do we say? Okay, this is a fixed effects model, so we're worried about model fit. And so the residual, try to make some highlighting show up here so you can see it. The residual statistic in this line is the one that tells you model fit is bad. This is an incorrectly specified model. The implication is that other variables explain variation in the effect sizes that's not picked up by dosage. And so then we'd be more interested in other stuff, I mean, whatever it is that especially you're going to start with your a priori models and go from there. So if you've got a database with 96 effect sizes like this one, you would hope to be able to evaluate more than 2 or 3 or 4 moderators at a time. And the beauty of the meta-reg command is that you can do that. So let's go back to our syntax again. Here it is. And I'm going to once again run my meta-reg command, and because I know I have at least one more variable that's continuous, for that matter, you could, like I showed you already, you can put categorical variables in here. MQS is the methodological quality score, and honestly I don't remember what it shows, but I just want to show you how it's this easy to add an extra predictor to evaluate multiple predictors in a meta-reg command. So our results show up like this. It looks as though higher quality studies got the same effects as lower quality studies. I would argue you'd actually want to look at the interaction between MQS and dose, but that's a more involved topic, and so we could think about that maybe later. For now, I would like to just focus you on these things. Adding the predictor in, if it's not significant, which you can see down here, right? The p-value is not less than 0.05. The confidence interval includes 0, so it's non-significant. Therefore, you wouldn't expect any change in the residual statistic, and in fact, it is still significant. Therefore, this is also an incorrectly specified model. You do pick up something with dose, and that's encouraging, but it's not everything you want to have in a model. Now, there's one more thing I'll show you if I can get back onto, there we go. So, in Wilson's README file, it shows you how to do them in other formats. So We've used fixed effects models right now. He has 3 different versions that you could use if you wanted to try to use random effects analysis, or formally speaking, you'd say to include a random effects, an estimate of the population variance. So you're incorporating random effects. Literally what's happening is you're putting random effects into the constant, and the slopes are fixed. That is, you're saying that effect size goes up based on some feature, or goes down based on some feature. You're fixing that to the moderator dimensions, whereas the constant itself is the thing that's getting the random effects variance component adjustment. So to estimate these models using this macro, and this is what especially, well, all of these things, Wilson's macros save me so much work. So it's a simple matter of just putting the model command at the end. So let's switch back to our syntax, and here we've got the model that we just did, and inside my period I'm gonna, and this is bad because I told you not to delete a command, but I'm gonna do it. Well, we don't really care because this is all fake data, but so here's a command that would, in theory, if I've got it right, I think there's a mistake. I've got to put a little slash there, and then this should work. Knock wood. Okay, and indeed it does. Now again, look at Wilson's output. Inverse, variance, weighted regression, fix it. Wait, this is not exactly right. So isn't this what I just showed you? And did it not? It looks like it didn't do my command. So I'm going to go back to Wilson's, okay, and see if I can solve the problem. So I'm going to copy his command out, go back to my syntax, because this did not work. And I'm blinding myself with the sun coming in the window, but okay, now we're there. So if we changed our, I don't know why he said random in there. I think probably he meant random assignment. So it's a misleading variable. That isn't how you get random effects when you say random. Behind IVS, you will have your independent variables, which we were just using as dose and MQS. And then over here we've got TW, and over here we've got D. And honestly, I don't know how that's so different from what and then it's got to be meta-reg. So here is what happens now. Yes, now we've got the correct output. So what it shows, okay, again, as I just argued, as I stated, it's a random intercept fixed slopes model. So this is literally a mixed model. Conventionally out in the literature, you'll see people calling this a random effects model, but I think it's better to say that you're incorporating random effects assumptions. So in this model, actually under random effects, it looks like none of our variables are working. The overall model test is not quite significant. If you look at individual predictors, dose does make it, but it's not as good as it was under random effects. And we see the same result with MQS. Here's the estimate of our population variance and the standard error related to that variance. And so, and then one other thing. Dave has talked about this a lot, and it's worth discussing in class. He and I have talked about this a lot. He's told me that he wishes that he had never put model fit statistics in these mixed models, because now people want to interpret them. When you go to a random effects model, now you're waving your hands at all that variance. You're saying, I'm going to attribute that to the population. Therefore, model fit does not matter anymore. So the residual statistic is not something you would interpret in a model like this. So ignore that. Yeah, so the bottom line is that when you go to random effects, the models automatically fit. I mean, it's magic. It's something else. Anyway, you can ask me all the questions you want about that, but I thought you would find that intriguing. And I think that that's everything I needed to show you with this. So if you go back to the meta-F stuff, if you want to do a random effects model with meta-F, and we had all our syntax in here, so you could still do it, and all you've got to do is change the end of this model command to do the same thing that we did with meta-reg. And of course it's not going to run unless you include the macro to run in the first place. Alright, so that should get you in business. I look forward to your questions. Bye now.